What's up, guys? I'm doing a video on checking the flame signal of a flame sensor. It was requested by a few people, so I put a video together. I know a lot of techs know how to do this already, and a lot of techs don't. So watch the video if you don't. And even if you do, I threw in a little bit of extra information. From that flame sensing terminal, there's actually an output voltage, an AC voltage there. It can range. All right, but on the unit that I was working on, I will show you what that output voltage is in AC. All right, before we move on, I have to make a correction. The last video I did was on evaporator formicary corrosion, and I was talking about a UPS in a server room with an AC unit and how the battery off-gassing can affect the A coil. Now the UPS, I called it a universal power supply. I should know better because that's not what it's called. My buddy Kenneth on LinkedIn reminded me. Thank you, Kenneth, for updating me and reminding me. It's an uninterruptible power supply. All right, just want to correct myself there, but let's get to checking that flame sensor. Okay guys, so this is a York rooftop and this is the ignition control board. Now in order to check the flame signal from the flame sensor, we need to know where it is. This is the flame sensing terminal here. Okay, if we follow this orange wire back down below into the burner section, there is the flame sensor itself. Now in order to check flame signal, we need to pull this wire here or down below and put our meter in series with that wire. I'm going to check this flame signal out using the Klein CL312. This was sent out to me by TruTech Tools, guys. Pretty cool little meter. So we have a few options on this meter. We have our volts, we have our amperage, microamps. This is where we're going to be checking our flame signal from. We have the opportunity to check diodes, capacitance and resistance, frequency and temperature. Okay, we check temperature with the type K thermocouple that comes with the meter, and the meter leads, of course. Now we can make these leads either short or extended by removing the cap. Pretty cool feature of that meter. And we also get a nice little case for this meter. Now this meter is pretty compact, it's not too big, and it fits nicely in a tool bag. So we're going to check the flame signal with this meter. So before we check the flame signal, I wanted to show you guys something real quick. I have the meter set to volts AC. Alright, now on the ignition control board, I have one meter lead connected to the flame sensing terminal and the other one connected to ground within the burner cabinet. Now, when this board here gets powered, when it powers up, we actually have an AC voltage to ground leaving this terminal. All right, we take that AC voltage and we rectify it into a DC current through the flame sensor. So I just wanted to show you the voltage that we are going to get on this particular board when I turn the machine on. Okay, we're calling for heat right now, and this board at the flame sensing terminal to ground is putting out 128 volts AC. Okay, you got to keep that in mind, guys. There is voltage present on that terminal. So now we're ready to check the flame signal. So I have the meter set to microamps, reading 0 there because we haven't turned the machine on. I have one meter lead on the flame sensing terminal, and the wire that's pulled off, the other meter lead is connected to that going out to the flame sensor. So when we turn the machine on and we get a pilot light, we will read a microamp signal on the meter. All right, we're calling for heat. Motor's running. Bit of a windy day here, guys, so if you hear some wind in the background, just bear with me. So there we have ignition, and there is our flame sensing signal. Just over 2 microamps. And again, we're connected to the flame sensing terminal and the wire that goes out to the flame sensor itself. We're connected in series with our meter. All right, guys, that's how you check your flame signal. And just keep in mind that you do have voltage. This particular board, just over 120 volts, leaving that terminal to ground. You guys have an awesome day and happy HVAC. Thanks for checking out the video, guys. Do me a big favor. In the summary of the video, I'm going to attach an article from HVACknowitall.com. In the article, it's going to explain flame rectification a little bit better. I know I showed you the AC voltage that's leaving that ignition control, but I didn't really explain how it works. That article will explain everything, and I've attached a YouTube video to that article that someone else has done. Okay, it's a really good video to show you how flame rectification works. All right, guys, thanks for watching the video, and if you like the content, guys, hit me up with a subscribe. That'd be awesome. Happy HVAC.